Kama. Today we will talk about array. Array is a collection of data. It permits us to to store a lot of data in a same variable. Okay. The classic variable we have seen, it was limited to store one variable. Okay, but array can store a collection of data. So small comments, we will see one dimensional array and two dimensional array. And about one dimensional array, the layout, okay, the declaration, layout, its type, okay, the type of the array, because an array at this level you can just store one type. Okay, in C you can store just one type, so the name of the variable, okay, is a variable, and then the square braces, okay, square braces to precise it is a array. Okay, it is, this is a variable, but when you add it, it become an array. It become array. Okay, so simple variable can store just one value like that, but array, when you have an array, you can do something like a collection of data, dot 2, 3, and many data. Okay, you can do something like that. So it's a variable, but a it's a collection variable. Okay, it's a aggregate variable. Okay, we call it aggregate variable. So it is a aggregate variable. Okay, and about dimensional array and declaration, it's layout declaration. It's not. Okay, so layout declaration here is type, name, and you have more than one square braces. Okay, dimension 2, you have 2, dimension 3, you have 3. Okay, and more. So let's do an example. I include stdio.age and int main. So I can create, for example, an array R. Okay, the name is R, and the size is 4. So that is the declaration. And if you want to store value inside, the first way to do it is with the name and the position of the element where you want to store. Okay, the first position is 0, we start at 0, and the last position is the size of the array minus 1. So the last element is array 3. So I can store at each element of my array different value. For example, here I want the value with two figures like that. Okay, so I have put values in all my table like that. You have another way to do it with a for loop. Okay, a for loop. Okay, let's show you how to print a value. Is the same thing. You do something like the array, the elements you want to print. Okay, so let's compile, and executable file is array. Okay, so I can execute 99. Okay, it's my first. So if you want to store at your table all the values directly, you can use the for loop. So I create, for example, another okay, so I can modify my array. I can do for loop like that. For I go to from 0 to 4, okay, plus 1. I print, okay, no, store I can store at current index, okay. I put I inside because I go from 0 to 4, okay. So the first turn is about 0. I store at first element, okay, index 0, and the second turn is index 2, second turn, etc. So you can store another array if you want another array. This is typical copy array, okay, if you want to copy an array. But here I have not specifically value, so I put I times 2, okay, for example. So I can store many value in this way, yes. So I can print all this value with the sum technique, okay. Here I print first test. Here I put second test, okay, my value backslash array I, okay. So at each turn, okay, at turn 0 I have array 0 here, so I print array 0. Turn 2 I have array 1, etc. I stop at array 3 because my condition, okay, I stop at array 3, and it's because the size of my array is 4. Okay, that is the methods to print all value in an array. Okay, second test 0 to 6. Okay, the value is I times 2. So I for 0 you have I times 2 gives 0. I times 2 also 1 times 2 2, 2 times 2 4, 3 times 2 6. Okay. We can initialize an array. Okay, let me create another array. I create an array R2, okay. I in this case I don't precise the size of the array, because in initialization when you do something like 1 3 or 5 like that, you have not obligation to precise the size, okay, because C understand you have the size 3, okay. By default it's a size 3 because you initialize with 3 values. So to print all this array you use the same method like this for, okay, to print the value, okay. It's the same array like this array, but we have initialized directly an array like that in the definition. So if I precise the size, I want to have size 10, for example, and I have just initialized with 3 value. The rest of value take zeros. So let's print to show you. The limit here is 9, and don't forget, inside a loop, okay, inside a block of instruction, any variable declare here is different, okay. It's just work inside, okay. That is why I have I here, I have I also here, I also here, and it's not the same thing because each variable is inside its own instruction block, okay. It's just a simple note. So the limit here is 9 because the size of my array is 10, and I can print yes and put third test. So let's compile. So for about the test starts here. I have 0. I have just put okay, I have done precise. It's array2. Okay, it was not correct. Okay, I have 1 3 5 for the first, but the rest take 0. Okay, that is the advantage of array. Okay, when you initialize, you can omit the another element, but if you have a variable like int a, and you don't assign this value, and you print, okay, you print the value of a, okay, you'll have an unpredictable value. Okay, that is because you always have, if you don't have a value to assign at a variable, you have to put 0. Okay, so let's test. You will see a random value, okay, each time. Okay, I have 0. So it is 0 because it's just by lucky. Okay, so let me declare here up to see the behavior of that. Let me take this print I print here at the beginning. It's always 0, but there are some cases where you can have an unpredictable value. So in this program is just by luck. Okay, I think it's because my previous tests before to do this video, I don't know, but pay attention of that. Okay, so let's remove it. Continue. So we talk about when I initialize just some values, the rest take zeros. I can use designator, okay, to initialize some specific value, so some specific element in my table. So for example, I can precise I want to store in index for the value, this value, and you separate by comma, and you precise another value, another index at index 8, for example. I want to store 99, for example. So you see at the index 4, okay, index 0 1 2 3 4, I have 99. At index 8 I have 99. Index 8 is here. 89 here and 99 here. Yes, the limit I have to put 10 here. That's the limit. The limit is 10. This 10 is exclude. Okay, it's exclude. So this loop go from 0 to 9. Okay, it's a small mistake. Okay, the 8 is here, 99, and the last takes 0. So at index 4 is here, 89. Okay, index 4, and the rest takes 0. So we have at the first value and the second value take this value and this value. Okay, it's normal. Okay, sometimes it's normal, but sometimes you can in fact this work like the first value of your array take it take this value. Okay, if I have another, okay, I have you have to note, you can do in any order. I can take in this two. Okay, I have 2 4 8, but I go back to index 2. It is not a problem. Okay, you can do with any order you want. I put here okay, 35. Yes, you see how the behavior of this kind of manipulation. Okay, the behavior of this is my array. Okay, the first three value take those three values. Okay, by default, that is behavior 89, 99, 35 by default, and then I have precise the index where I wanted to store it, so it respects it 99 at 4, 99 at 8, and at 2 it is not, yeah, it is respected 35. Let's change from 7, okay, or 5. I want to show you something. Okay, you see the 2 respects the 2. Okay, wait. Okay, at 4 I have 89, at 8 99, and at 5 I have my 35. Okay, so for the three first value you have 89, you have 35, at 35 again. So you cannot predict well the value of those three first value, but you have precise the value where you want to store. Okay, is respected, and then you can mix with the last type of assignation. So lastly, let me create another, that is array 3. I want to show you the difference. Okay, let's go down. About array 2, I will have something like values is 0, 9, 3, and maybe 5. Okay, I here I just omit the rest. Okay, the rest is by default take 0, and here is about designator. Okay, designator is this type of operation when you precise where you want to store in initialization. So I want to print. So yes, that is the fourth test. It's about array 3. So okay, I wanted to explain something. You can mix this type of operation and this type. Okay, when you precise 4 like that, you can continue for the next value you precise, for example 43, and then that is for index 5, and the next is for index 6. Okay, comma, like that. So let's test. You see, for the photos I have 89. Okay, let's go from index 4. Okay, 0 1 2 3 4. I have okay, which I 3, yes, I have 89, 43, 55, 99 at 8. At 5, I supposed to have 0, 1, 2, 3, 4. Okay, 5, I have 35, yes. And at array 4, I have 1, 2, 3, 4. Okay, there is a shift here. There is a shift here. That is because you have to avoid this type of operation. Okay, you have to avoid it at maximum, but I think it's because the table your computer considered this table like full. Anyway, I come back later about this type of operation because it's more sensible. Okay, it's interesting to explain it by address. Okay, by how you call it. It's more interesting by pointer. Okay, by pointer. I come back from this type of operation. Let's continue. I think it's okay for one dimensional. Okay, about two dimensional array, I can create an array like array for with two line. Okay, two line and three column. Okay, that's a two-dimensional array. You can have three-dimensional too. So to initialize it, for example, you can do something like that, and then comma. You can go to the line to make it okay, to make it like a real table if you want, and you have not obligation to do it like that, but sometimes it's okay, for two-dimensional it's better to do it like that. Okay, or you can okay, let's just do it like that. Okay, 4, 5, 6. So I have two table inside one table. Okay, it's a two-dimensional array. To get, for example, this value, okay, I just do something like array. The name of my array is array4, and it's a second table. Okay, index 1. Okay, don't forget I start at index array start at index 0, and the index of this value is 2, is 1. Okay, the second value. So that is how you have to do when you want to access a value. So I can print this value, for example, I can print this value, that is a fifth text. I can print this value. Okay, you see 5. Okay, it is this value. Okay, if I want to access this, okay, or this, it's index 0, the first table, and the position of this value inside this table is 2. Okay, 0, 1, 2. So we have 3. Okay, 3 is printed here. So that is about, you can do the same thing for three-dimensional array and so on. So to for example, you can change this type of scripture by do just 1, 2, 3, and then go. You can, to present it well, generally do something like 1 2 3 and go to the line 5 6 7 separated by comma. Yes, you can do something like that. Okay. When you have a very big array, it's better to do it like that. Continually store like that, so you don't precise. That is the first collection. Okay, you remove it. Okay, you just have a continually scripture like that. So your computer understand that you have the first and the second year. Okay, because when you finish it, there is no place again to store more. So your computer shifts. Okay, it go directly to the second emplacement. That is why I write it like that. So it is another way to write it. Okay, I always my tray. So if I precise a table 1 index 1, it is value, okay, 5 7. How is 7 second? Yes, it's 7. Okay, the last value in table 2. So you can write in one line if you want, so you can write it in one line like that. Okay, it's possible, but it's better to present like I've presented like that. Okay, it's better like that. So I think that's all about this video. You can print the size, the length of your array by use size of. Okay, I can print, for example, the size of which array of this array, the size of array 2. I just do something like present the array 2 size of. Okay, I use the function size of array r2 like that. Okay, that is it. 40 because size of, it's supposed to print the size of a type. Okay, but the type int as size 4, size size 4. Okay, 4 octets, 4 bytes. So that is why you multiply the size of this type, okay, by 10. That is why we have 14. So if you want to print the size of the array, the size of the array itself, so the size of the element inside the array, so this size, okay, the size of the array itself, if you want to do it, you just have to divide by the size of the type concerned, type int. That is the method type 10. Okay, that is the method to have the size of an array. You will see the method, the better methods to do it. Okay, you have function to do this type of operation. Okay, to make it easy. I think that's all for about this video. I've already created the exercise about it. Array.txt. You have to construct 4 times 4 identity array. Okay, identity array. It looks like identity matrix. Okay, identity matrix like that. One. Okay, it's like that. 4 times 4 like that. With the 1 at the diagonal. Okay, it's an identity matrix. You have to do it. The results look like this. So that's all for this video, and see you soon. Take care of you, Nakama.
Portrait comme au Beaux-Arts, loyal, poli, droit et sincère. Je respecte le code du Bushido. Mais si on met les armes à terre, c'est pour te faire une prise d'aïkido. Et la concurrence au cimetière, ne pensez pas mourir aussitôt. Mon katana taille leurs artères et broie leurs organes génitaux. Quand j'étais gauche, j'en ai pris des coups, j'en ai dans le ventre comme un sépou.